Hi and welcome to Fresh Thinking by Snowden Optiro, a podcast where we delve into the technical aspects of the mining industry. My name's Tarrant Elkington, General Manager for Snowden Optiro here in Perth. Today we're going to talk around mine planning and particularly around the selection of a final pit, which is an important parameter in mine planning. And joining me for this conversation is Pedro Ladiera. Pedro is a senior consultant here with us in Snowden Optiro, based in Perth, and has more than 15 years of experience in mine planning across a range of different commodities, being based in Brazil originally and now here in Australia with us. So it's great to have you here with us, Pedro.
Thank you, Tarrant. I bring my Brazilian accent for the podcast today.
Well, I'm glad we're doing this in English. One day, maybe we can do it in Portuguese. But, So just to start, can you just maybe explain to us quickly what is the final pit? What are we talking about with this thing? Why is it important?
Yeah, definitely. The final pit is the final boundary and the limit of our open pit operation. So is the limit where your revenue will be higher than your cost. So anything above this limit will reduce the profit of your project. So it's the limitation of your open pit operation.
And what's the important thing about the final pit?
Yeah, I think that the first one is to limit the maximum amount of material that you can extract from the pit, understanding the size of your operation, the amount of ore and waste, and as well will be the starting point to start the mining planning. So will be the point where you break that in stages and you start to planning how you will extract at each step of the pit.
So we can determine how much once we get to that point, we know how much ore we've got.
Yes.
What sort of production rates that we might be able to achieve, and then also what are the possible extents for infrastructure.
Knowing this limit, you understand the footprint. And you can start to planning where you create your waste dumps or your infrastructures or all your processing plant infrastructure in your mine. So you will be the starting point for the whole mining planning and the long-term planning. So this will be the starting point.
And so how is if we move on to how do we actually figure this out? How do you determine what the final pit should be?
Yeah, it's interesting. We have different methodologies to do that. We can run the pit optimization normally using the Lerchs-Grossmann or the Pseudoflow algorithm, where the algorithm will define what will be this final shell, calculating the benefit of each block from the resource model, and understanding what will be the impact of mining this block, applying the geotech parameters and the slope regions. So these algorithms will calculate the processing cost, the mining costs, and the revenue from the operation, and then we'll define what will be the final extension.
And so when we talk about the final pit, is it an exact science? So we go do a pit optimization, we put the parameters in, it defines. It's a mathematical solver, right? So it generates something. So is it a given that we just take that pit and that's it?
No. So the algorithm help us giving the final boundary, but we take into consideration all the parameters, the economic parameters, the operation parameters, and also these slope angles, and we calculate for some specific price, for example, and costs. So imagine that the current price and cost for one commodity, we apply this and we get the shape. However, when we are selecting this shape, we could do an assessment and see what would be the impact if we change the price, if you have a lower price, for example, if we are predicting that the price can drop in the future. So we normally do a sensitive analysis in one of these parameters, one of these modifying factors, and to understand how the pit will vary, for example, when we change the price or the mining cost. So a really common approach is create some revenue factors where we will create incremental shapes and assess these shapes that we call pit shells. So let's say our final pit is calculated, our final shell is calculated with the current price, but we can apply a factor for 95% or 90% of this price and see what will be the impact in the final shape. Doing that, we have a series of shells, nested shells, and we can start in the assessment to see what is the strategy of the project or the strategy of the company, if it's aligned with the selection of these shells.
And so with these revenue factors, and typically I think we call the pit shell that's generated at your base price assumption as the revenue factor 1 pit. It's designed to maximize cash flow, right? The undiscounted cash flow based on all of the parameters, the long-term parameters that you've given. So what's the limitation of that? Why might that not be best?
Yeah, so like when we are calculating this, the final pit, when we're doing the pit optimization, the algorithms are undiscounted. So they don't know when we will mine each block. They just give us the final limit. So having this final limit and having these pit shells, we have all the constraints that will guide our scheduling, which will be like the vertical rate of advance that we discussed in a different podcast, and other rates that can impact how fast you will mine these shells. So let's create an example. We have the revenue factor 1, which is our base price, but we have a revenue factor of 0.9. It's 90% of the base price. So between these two shapes, we have an amount of material, of ore and waste, that will be only viable if we get the base price. However, if we think, let's give an example that is a deep mine, 300 meters depth, and we cannot mine these 300 meters in 1 year. Let's say that we need to mine, we get to the bottom in 3 years' time. So the ore that is located in the bottom of this pit shell, we'll need to mine 3 years after the waste on the top. When we are applying some discount for that, like let's say 10% of discount, this ore will be discounted by 3 years. So actually, the revenue that you came from this ore will be less than the undiscounted. And sometimes these incremental pit shell for the revenue factor 1 won't provide you the highest NPV. So this is why it's so important to do the assessment, to choose which pit shell is your final pit.
And are there any tools that can help us to apply that logic that you're talking about?
Yes. We can, as mentioned now, we can do a discount by depth and applying, let's say, by a number of benches, we are going to discount these profit from the blocks. So in terms like the first 5 benches, we will not discount the benefit, and then the other 5 bands 10%, and then more 10%. So if we apply this discounting, when we are calculating the pit shells, we can plot a chart and see what would be the impact in the NPV of adding these incremental pit shells. So it will be easier to the mining planner to see that and to choose which pit shell will correspond to your highest NPV.
And I think there's other approaches now that are being developed, mainly direct block scheduling, right? Which is coming into this space. Can
Yeah.
you explain a little bit what?
Yes, definitely. Like we have new technologies, we are evolving, and there is a direct block scheduling, which is a little bit different. On the final pit by Lerchs-Grossmann Pseudoflow, we get the final pit and then we break in stages and get the scheduling by the end. But in direct block scheduling, so the algorithm will group blocks and will define the period as like the first period, the second period, and by the end, when the optimization can't find any other period, this will be your final pit. So is the other way around. Instead of finding the final pit and breaking, we're just getting the years, and at the end, when you cannot add another year to your scheduling, will be your final pit.
So you're trying to, I mean, basically combine the pit optimization and scheduling step into one.
Yes, definitely. It's a really interesting one, and if for some specific commodities is more interesting to try this approach when you need to blend in some contaminants or when the stockpile has a critical role to this scheduling. So it's worth trying this methodology and see if the impact will help you to get more years.
Probably the topic of another podcast for us.
Yeah,
definitely.
definitely.
I could probably talk for a while about direct block scheduling. So, but it's definitely an interesting different method that's quickly evolving in the industry. I guess we're talking about trying to sort of precisely define our pit shell, but where we live in a very uncertain world with very uncertain prices, and price is a huge driver of so how how sensitive is the value of a project to that the size of the pit that you choose?
Yeah, so definitely choose a pit shell is an important step on the project. But sometimes it's not the most important one. Like there are other factors that will impact more the value of your project instead of selecting, let's say, the pit shell of revenue factor 0.8 or 0.85. Because when you are selecting your pit shell, we are probably the difference between one and other shell will be the end of your schedule, because it will be the less incremental shell that you are adding or removing. So then sometimes adding that or removing that, if you do all the project and the scheduling, you will see that the impact is not material to your project, and other items could have a bigger impact, like your constraints or your ESG constraints in your project, your facilities. If you need to relocate any infrastructure, could have, or have any capex and even equipment, could have a bigger role in your project instead of select the pit shell. So it is important, but sometimes between one or other shell, the impact is marginal.
Yeah, I think the point you make there is really relevant in today's market, where it's sort of try to help you define where not to put infrastructure, because I think just about every study of an existing operation we're doing at the moment, we're mining waste dumps that were designed or were put in some place at some point in time, moving plants, crushers, infrastructure, expensive infrastructure, because the pit has expanded more than somebody anticipated in the first place. And that does come to looking at potential, not just things like one's looking at advances in price, but also looking at increase the like resource potential or exploration potential for the future that you need to be thinking about, where that potential final pit. One thing that I've oscillated on the final pit selection and, thought about it a lot, And one interesting thing that I've found is, and I went and tried to test a few examples that I've had from my past, and like there can be a wide range of pits that you could choose that will probably generate a similar value. So in that context, as you say, maybe, which one you choose within that similar range is not all that important. Maybe the bigger one is good because it might give you the potential to have a bigger scale, lower unit costs and things like that, but also choosing a bigger pit might drive you to more capex than you need to spend. So I think it's both not important in a way because it doesn't really potentially, you could choose a wide range and it could be, have not a huge amount of change in value at a price and hugely important. And I think, as you said, with discounting, the first, few years is the most important. So if you have a pit shell that is only 5 years worth of feed, then it is really important to get it right because it might be the pit that you actually go and mine.
Yeah.
If you've got a 30 or 40 year mine life, the one thing I can tell you is that's not going to be the final pit that you end up mining because things are going to evolve. But whatever you do in that first 5 or 10 years in your payback is the most critical. And that's something I think, from my experience, people spend a huge amount of time working on their final pit selection and much less time working on their starter pits.
Yes.
And an initial cutback development, which is, to me, a lot more important for, and maybe we could talk on another podcast around pit staging and the use of, pit shells for that, which I think would be quite...
Yeah, definitely. Like the pushback development strategy and how you start to open the pit has a big impact in your payback and in your NPV. And something that it's related also with the operation. And we can think in terms of the pit shell selection is like when you have these small pits with a short life of mine, or when you have some shallow pits, we tend to go to the revenue factor 1. Because
Sure.
For example, short pits and small pits, you have a potential to expand that in the future. And if it's shallow, you don't have the impact of the discounting and the vertical rate of advance in your optimization. But when you tend to the other side, some deep mines and deep pits, you tend to look more for the incremental shells and see which one will have like a more strategic impact in your project in terms of the amount of waste and pre-stripping and what is aligned with the company view.
Absolutely. I think it's one of the nerdy, exciting things that we get in mine planning is that every project is, it's cliche, but every project is different.
Yeah,
and
exactly.
so everyone needs to be looked at in its own strategic context, which is what makes it interesting. But I think we might leave it there. I could go on for all day. But thank you very much, Pedro, for joining us again today.
Thank you, Tarrant.
And thank you all for joining us on this episode of Fresh Thinking by Snowden Optiro. Hopefully you enjoyed it and you might want to subscribe to our podcast on YouTube, Spotify and other podcast platforms. And I look forward to sharing more technical insights from the mining industry in future podcasts.